Yes, question.
Is there any like a video recording of this presentation at all possibly?
Yeah, it'll be like normal. We'll have a AV lecture recording of it.
Okay.
Is that what you're asking?
Yeah.
Yep. That's what I just started. So your question is now
Oh, no,
the
not
first
this.
item on the
Not
lecture.
this lecture, but this presentation that you are advertising.
Oh, of the conference? No, not that I'm aware of. I don't think there'll be any recordings of it. All right, so today we have a guest lecturer, Dr. Michael Miller. He finished his bachelor's degree in general experimental psychology, and his master's was in experimental psychology, and then he moved on from Roosevelt University to the Illinois Institute of Technology to receive his Ph.D. His Ph.D. was in physiological psychology. He has a big clinical background, even though he's Ph.D. trained, so I thought it would be rather interesting for you all to hear about many of the disease states that you're learning about a lot of the alterations or problems that take place with the nervous system. Primarily we'll be focusing on the central nervous system today. You have the lecture slides that were posted online. I'll have a recording of this online as well so you can look back at it. The videos that he's going to show today are also loaded on YouTube, so you can actually go and re-watch those. Some of them are older videos, so the sound quality may not be as superior as you would like, so if you listen to it again, you can put headphones in, that sort of thing. He has a very colored career in a number of different positions. I'm not going to go through all of them. I'm going to highlight a few. He's spent time supervising third-year psychiatry clerks and psychology interns at Rutgers University. He performed a number of forensic neuropsychological assessments related to head injury and head trauma. He did a lot of cognitive direct assessments with patients, primarily with Huntington disease at the Family Center, Service Center for Huntington Disorders. He developed a cognitive testing battery to assess different types of dementia. One of the ones that I'll talk about today is Alzheimer's, but it's not the only one. He was a director of the Cerebral Dysfunction Clinic and the director of the multidisciplinary dementia diagnostic and management clinics. And then he was the chief of the neuropsychological services, the division of geriatric psychiatry. So he has a decorated past. He's retired. He taught at Rutgers Medical School in New Brunswick. And so it's a privilege for us to have him here. Please join me in welcoming Dr. Miller.
What's this for? First of all, PhDs are not trained. PhDs are educated. Medical students are trained. Medical school is a trade school. It's a medical school. PhD is an educational career in any discipline. So you just learn how to think, you learn how to do things, and it's not specific to any science or philosophy or sociology or anything. So let's clear that up. Second thing is, I always wonder how quickly to go in my lectures here. So I'm going to do a pre-lecture quiz. Who knows what the central sulcus separates? So you have to go real slow.
Is it the pre-central gyrus and the post-central gyrus?
Well, of course, the sulcus is going to separate the gyrus because you have a gyrus and a sulcus. But what functional areas does it separate?
The frontal and the
What functional area? Functional.
motor, and separates motor from sensory.
There you go. All right, very good. Got it out. Excellent.
I'm so proud of my class. Whew, that was nerve-wracking.
You're right. This is a test of Dr. Kelly. What connects the left and right hemisphere?
Corpus callosum.
Okay. Good. That means I can read real fast. All right. Woo! Okay, so the topics today are going to be clinically focused. You've had all kinds of molecular presentations of how the origins, the molecular origins of various dysfunctional conditions. And what I'm here to do is just to amplify that into clinical presentation in terms of the various diseases that might they may be part of. Dr. Keller, you know, it's interesting the parts of my career that he picked up on his presentation. I've worked with primates, I've worked with rats, cats, monkeys, and I just moved up the phylogenetic scale, finally to working with humans, because human brains are just that much more interesting. Although we have a close relative. What do you think our closest relative is? Is it a primate? Of course, it's a primate. What primate? Chimpanzee. I hear chimpanzee. No, it's the bonobo, which is a subtype of the chimpanzee. But they have remarkable behavioral similarities to human beings in many, many dimensions. And if you're curious at all about, you know, the phylogenetic progression of development, it's very interesting to go ask Mr. Google about bonobos. And it's quite fascinating. And another reason I worked with humans is because even though you weren't allowed to do experiments on humans in terms of intervening and causing lesions, Mother Nature and diseases and other people seem to cause central nervous system impairment, so we can study it. And by inference, we study what the damage is and what the result is, and then can generate hypotheses on the function of different parts of the brain. And that's how clinical neurology has advanced over the centuries. The biggest impetus to the study of neurological diseases, brain function, brain deficits are wars. Because wars give you lots of people with injuries that you can study. And it's an unfortunate aspect of humanity that we have to do that in order to have our best progress in function. The fact that we continue to have wars is an interesting comment also on how human evolution doesn't necessarily go forward. Sometimes we regress to those means time and time again. But let's focus now on the history of the study of clinical deficits in terms of brain damage and behavior. So this is the latest. It's probably about 1910. So it's only a few years old. What do you think this is doing? Yes?
Is this one of those things that, like, they open up your brain and then they jumble your brain around, and they thought it would help in certain
No, those are things they're doing now. That's way back. You have the right idea in the same way they had the right ideas. The idea was that, gee, maybe the brain has something to do with behavior. That was the concept. And so they thought by looking at the brain, you could then infer behavior, just as I said before. However, in those days, in the 20th, early 20th century, 19th century, anytime you opened up a skull, you got an infection, the person died, so there was very little to study. This way, they could measure the skull and infer and interpret what's going on in the brain underneath. And that turned into a quote-unquote science called, usually somebody in the class knows the term. Yeah. Exactly. You're the guy in the class that knows. I think you were here last year, though, too, weren't you? or you'd learn something. Yeah, phrenology is a pseudoscience, it really isn't. But the idea was correct. If they could measure the bumps on the skull, and they know that, or they thought that this bump was memory, and you had a big bump there, it inferred that you had a good memory. And this led to, all kinds of analyses that were far flung from the actuality, but at least it pointed in the right direction. And finally, antiseptic techniques intervened and developed, and they could open up brains and look at this, not only the skull, but the tissue itself. And that spawned the science of cytoarchitectonics, looking at the cell structure. And if cell structure was specific, they thought maybe cell structure is specific to certain kinds of behaviors. And lo and behold, different parts of the brain have different cell structures. And so they, in the decades of the middle of the 20th century, started looking at these cytoarchitectonics and trying to correlate what kind of cell mediated what kind of behavior. And it turned out to be largely unsuccessful because there are many kinds of cells, but they don't really correlate specifically with behaviors. But at least it was progress, right? They got into the brain, starting to look at the neurology with good microscopes and good analytic techniques. Then, in the 30s, they did further studies. They were able to deal with an open skull and stimulate the brain with electrical current. And while the patient was awake, they could observe the patient's behavior and the patient's comments. And this was very valuable in the study of epilepsy, because the idea was to remove or excise the pathological tissue that was precipitating the seizures. So a gentleman, Dr. Penfield in Montreal, would stimulate different parts of the brain and see what it elicited in terms of language, pain, movement, whatever. And if it correlated with the person's aura that preceded the seizure, because epileptic seizures have an onset that's experiential by the patient. And if that could be found, what tissue is precipitating the seizure, then you could excise it and eliminate seizures. And we're going to see a patient who had a similar kind of ablation, and to show you the behavioral result. But this was a big advance. And then subsequent to this, in the 30s and 40s, lots of medications were investigated, and anti-epileptic medication has proceeded very measurably to the present day, when virtually 90–95% of seizures can be controlled with medication, and you don't have to excise the brain or do other procedures that we'll see later. By the way, if anybody has any questions at any time, just say something. So from the 1930s, this is to the present, in which we can still read what's going on the surface of the brain. These are electrodes placed on the cortex to either stimulate or record different areas of activity of the brain. And so we're still using the same techniques, but with a more elaborate and precise electrophysiology to do the studies. So things change, but as they say in French, plus ça change, plus c'est la même chose. More things change, more of the same. And over the latter part of the 20th century, the investigations showed that there were lots of pathways that connected parts of the brain that were functionally very similar. So certain parts of the brain are connected in long longitudinal fibers from back to front. Then there are fibers that connect different areas near the cortex but at different levels. And then there's a whole number of connections that actually turn out to be illustrative of the way the brain is organized. And just to show you one example, this fasciculus, anybody know the name of this fasciculus? Fasciculus is a fiber pattern. This goes beyond the corpus callosum, so we're getting a little more. You look like you might know. The uncinate fasciculus. It connects the Broca's area to the speech reception area. And as you know, Broca's area is in charge of what aspect of speech? Of language. Right, it's a motor area, it's for production. And that was, you know, again, that sort of historical exploration always fascinated me. Now, how did somebody decide that that's the area that produces speech? Well, there's a hospital in Paris that still exists, and there's a set of streets in the 13th arrondissement in Paris where the streets are named after all these scientists who worked there. Broca, Pascal, a couple of others that I can't remember now. And Broca's hospital is still there. And he noticed a patient who had difficulty speaking, and he died. And when they did an autopsy, they noticed that the third frontal convolution on his left hemisphere was diseased, which happens to be right there. And so then that piqued his curiosity, and anybody who has language difficulties went to Broca's clinic and died. I don't know about the relationship there. I don't think you wanted to be in Broca's clinic. But sure enough, it turns out that motor speech is located in that part of the brain. And other areas of the brain were investigated in similar ways. And that's how science progresses. It goes as, I don't know if you know the scientist, Stephen Jay Gould, who was an ethnophysiologist, studied many areas, but he had a principle that I think applies to so many things, and it's called punctuated equilibrium. In other words, things don't progress in a linear, rhythmic way. There's long periods of tranquility and stagnation, and then there's a punctuation of activity that moves the science, or let's even call it climate change or things like that, forward, and then there's another area, calm area, and then there's more disturbances. And that seems to apply in many areas of inquiry in scientific, naturalistic domain. It's worth looking up. He was a really good scientist. So, we've progressed to knowing there are pathways, we know there are cell differences, cell structural differences, and how to put it all together in order to know how the brain is organized. Yeah.
What is the uncinate again?
Uncinate?
Uncinate.
U-N-C-I-N-E-T.
Okay, what that connect to?
It's the Wernicke's area and Broca's area. Wernicke's area is speech comprehension. Right. Now I lost my train of thought. You derailed. So how do we put together all of these aspects of brain investigation? When you're old, you're easily distracted. Be careful of that. I guess it becomes cumulative. You know, in our present day and age, we are dealing with so much information that has been accumulated over the past century, the 20th century, when things really came together. Now it's going exponentially. So, you know, you can Google any one of these things in terms of brain function. You see the whole history right then, you know, within seconds. But back then it was a lot slower. And for many years, as the study of brain function developed, in the 1990s was the decade of the brain. Everybody thought that we had it all together. We had CT scanning, so we could see what's going on in the brain. We had all of this neurophysiology that had been accumulating over the 20th century. And now we know how the brain is put together. Well, it turns out the 90s were pretty tranquil in terms of brain studies, because what the imaging was doing, the imaging was just confirming all of the clinical observations that people had been making over the 20th century. In other words, when a person had damage in Broca's area, the person didn't speak, and you can look at the CT scan and you can see the damage. Well, that's very nice, but we knew that already, you see. So it was a relatively stagnant area in terms of scientific process. And it's evolved now to the present, where not only do we have CT, we have MRI, fMRI, PET scanning, we have biological radioactive tracers that we can look at, magnetic imaging. So all of these things are finally now pushing the science forward in terms of, you know, how the brain works and how we can sort of stop the progression of diseases. So now things are really going to explode. I mean, in the next 10 years, you're going to see real understanding of almost the subconscious. There are people that say that you'll be able to walk into the house and think that the TV should be turned on, and it'll be turned on. Now, I don't know if that's going to happen, but there are books out that predict that kind of thing. So you're in a good place in order to watch that or participate in the progress that's really going to be happening in the medical field. Just a little parenthetical, my daughter graduated from college in '94, and she was part of a class, you know, and everybody did different things. It was in Silicon Valley, so people were in the right place at the right time. And many people, many of her friends, when they graduated, I asked her, what are you going to be doing? And she said, well, a lot of my friends are going to become consultants. So I said, consultants? You just graduated from college. What do you know? What are you going to consult about? Well, you know, you had no experience to consult with. Turns out they were right at the beginning of the internet, coming of age. And many of them didn't really do the consulting. They joined the social networking firms that are, you know, were born in Silicon Valley. And they became multimillionaires and multi-billionaires in a matter of years. But it's like winning the lottery. You know, you got to be at the right place at the right time, and the odds are not with you. As a matter of fact, my daughter was cited as one of the failures in that class, her and a bunch of her colleagues, because they didn't join these internet firms. They just went to medical school, they became business people, and developed various entrepreneurial skills. So they were the losers. It's all relative. So, understanding the fibers. It turns out that this is an electron microscopic view of neurofibers in the brain. And it turns out that they're not just scattered about in some random way. The process of, anybody know what the name of when the nerve cell migrates from one point to another? It's called neurobiotaxis. And it's an important process where things can go wrong in the nervous system. And it's a thing to watch, especially developmentally, in terms of autism in human beings, in terms of people's strengths and weaknesses. And so the neurobiotaxis turns out to be a very regulated kind of phenomenon that exemplified in beautifully crisscrossed nerve fiber pathways in a very organized way. And that was not predicted before electron microscopy. So that's an interesting finding that's quite recent. So taken together, how is the brain organized? I mean, how many cells are in the brain? 100 billion. It's a fairly large number. The 100 billion, though, that's often referred to is really minuscule, because what it means is there are just 100 billion cells, but it's the synaptic connections that are proliferated that really form the big numbers. And so that fantastic number of cells and interconnections sort of sifts out to be organized in, I look at it in terms of 3 different dimensions. Caudal to rostral, caudal meaning the tail to the head, in other words, the bottom of the nervous system, from the spinal cord all the way up to prefrontal cortex. The sensory motor dichotomy, sensory motor being, who's the woman that had she had it nailed already. In other words, the posterior part of the brain to the anterior part of the brain. That's one dimension. And the other dimension is left-right. You know something about already. So here we can schematize the pathways going up and down the spinal cord to different parts of the cortex. The higher cortical areas being responsible for much more complicated higher order processing. The lower centers, the midbrain, the pons, the medulla, for basic regulation of autonomic functions and temperature, etc. So that's the rostral caudal. So if you know that there's a lesion in the pons or medulla, you don't think there's a language problem, right? Because language is mediated way up in the cortex. So right away you have an idea of where the lesion is, if there's a temperature regulation problem. Similarly, in terms of anterior-posterior, you know that information comes in the posterior part of the brain and moves forward. So as sensory information moves forward, it becomes reified and elaborated upon and goes up into motor cortex and premotor cortex, which is sort of the decision-making part of the brain in terms of what do we do with the information. And then the left-right, shows the left hemisphere, and the probe being on probably the auditory cortex. So what we have basically in the left-right organization with the corpus callosum in the middle is not a complete separation of left hemisphere versus right hemisphere, but an integration of the 2 hemispheres with the corpus callosum. And you know the basic functions of the left hemisphere? Anybody just thought out a few?
Spatial awareness. Spatial awareness.
Wrong. Left hemisphere.
Analytical thinking.
Political thinking?
Or analytical.
Oh, analytical, right. Analytic, exactly. What about the big one? Language. The left hemisphere takes the lead in language, not exclusively, but the left hemisphere takes the lead in language in 95% of the population. Even if you're left-handed. Left-handers have the right hemisphere dominant, but not for language, usually. There are a few that are reversed, but not often. But the left hemisphere is analytical, it's sequential, it's numerical, it's calculating. It's got all of these sequential, ordinal relationships. The right hemisphere is, it's all written up there, see? But can you synthesize it and just put it together in conclusion? The right hemisphere is more holistic. It's non-specific. It's musical. It's, what contribution does the right hemisphere make to the language? Poetry is influenced, right? The rhythm of the language is poetic. Anybody here? Prosody? Prosody is the intonation with which one speaks. So, if I talk this way, it's very different if I'm expressive and I can modulate the tone of my discussion. And that aspect of language is mediated by the right hemisphere. And because the right hemisphere is connected to the left hemisphere, well, of course, the corpus callosum, the anterior, posterior commissures, then at the level of the midbrain and pons. After all, what does pons mean? Latin.
Artery.
What? A bridge. It's a bridge. So it's a bridge. There's a bridge between the left and the right hemisphere. So the whole ball of wax is a brain that certain areas take a lead, but other areas are also involved. And that's very important, and we don't have time to go into it today, but in terms of brain damage. Because if you have brain damage, not only do you have the damage in the area, you may lose, let's say it's right in your Broca's area, so you're not going to be able to speak, but you lose language, but you also lose all of the connections that that language area had to other parts of the brain. And so there's a term is called diasthesis. Look it up. It means that you not only have central damage at the point of damage, but it can have a more distant effect. Okay, I'm going to refer to that in a minute. So it's a very complicated bilateral arrangement that by which we're able to shift from one intellectual process to another intellectual process in normal individuals. And the important, this is, I think, one of the most important slides, because all of these functions of which I just spoke have an ontological component. What do I mean by ontological? A developmental component. In other words, we're not static in our, we don't get born as adults and then die and then that's the end of it. And you don't stay a child your whole life. There are changes over time. And those changes over time are profound because in terms of hemispheric specificity, in other words, the specific functioning of each hemisphere, because we said each has its own functioning. The left hemisphere at birth or prenatally has very similar functions overlap between the two hemispheres because not a lot's going on prenatally in your hemispheres because they're so undeveloped. But as birth comes upon these functions, these cognitive functions are shared by both hemispheres. And as, again, between 0 and 5 years old, you're not doing a lot of high-level processing. You know what's happening? What's happening? Are brain cells being added to your brain? What's happening? You're shaking your head.
Well, it's like you said, they're developing. So you have the initial brain cells,
Right, you have, yeah, go ahead.
The connections chained up, and they create new circuits.
Yeah, new circuits are being created. In other words, you make a circuit because for whatever you're doing, and that strengthens that circuit. Every time you use it, it becomes stronger and stronger. But more importantly, what you're getting is pruning. You're getting cells that are not being used dying off. And so the brain is changing so that the used ones get more used and the unused ones die off. It's a use it or lose it phenomenon in spades. Because, you know, if you're going to be deprived of sight, let's say, visual cortex is not going to develop. And other kinds of, you know, sensory motor linkages are not going to be developed. That's why it's good to become a tennis champ when you start playing tennis at the time you learn to walk. Because you're strengthening those connections, and those are the ones that develop the highly skilled, whether it's tennis or music or what have you. So you got to start early. You guys are all too late. Me, I'm on the downslope, so that's a whole other. But I have to see my tennis game. I have to outsmart the young kids. So you guys are going to hit the ball as hard as you can, but I'm going to hit it. Going up the phylogenetic development, as you get older, the hemispheres develop competencies, differential competencies, that we just spoke about. And they share fewer. So they become more specific, more process specific, more functional specific. To the point when you're fully mature, which is, you guys are just about there in your 20s, early 20s. But, you know, then it's downhill, so enjoy it. You're at the cusp. Their specific functions are disparate, okay? But they're shared because you have the connections. So if you have brain damage, this is the question. When do you want your brain damage? As an adult or as a child? Oh, wait, you're going to get a chance to vote. You only get to vote, you don't get the chance to choose the damage. When would you choose to have the damage as a child? How many as an adult? Well, it's heavily weighted in terms of child brain damage. Well, you're past that, so you're home free. However, it's not necessarily the case. Because if you have damage as a child, right, an area of dysfunction appears, but what does the brain have a remarkable ability to do? Neuroplasticity. The brain, as it develops, can compensate for damage to different areas. So, as you develop, even though your language, let's say, is impaired, you develop other skills to compensate, and the brain rewires itself, or in that case, wires itself to compensate for that deficit. What happens if you have the same damage in your Broca's area as an adult? You lose the language, right? And you're not going to recover a lot of language the older you are. Of course, it depends on the size and the place and all that. So, given that, you still vote for damage as a child. But there's one disadvantage to having damage as a child, and that is you don't get to develop a brain of an adult. You have a brain that's impaired and rewired, but you'll never have adult thinking. I mean, that's what is the basis of mental retardation, cerebral palsy, and all of the perinatal illnesses, is that people don't get to function as an adult in terms of abstract thinking, higher level cognitive processing. Whereas if you have your damage as an adult, you lose that specific that specific modality, but you still have an adult brain that's capable of abstracting and inferring and doing all of the things that adult brains do. So there's no real right or wrong answer. It's just depending on when the damage is, you're going to have different sets of deficits. Okay. Do we give them a, what, 12-second break at some point?
10 seconds.
Soon, or?
No, I would keep going.
Keep going, okay. So let's put it together in terms of information coming in. What happens to it? Comes in, you get somebody lecturing in your lecture hall. What happens? Well, you have to attend, you have to concentrate, and you have to remember something. Now, you have so many props these days. Now, look, they're taking pictures of me. It's all on YouTube. It's in Dr. Keller's notes. It's in the book. It's in Google. It's in everywhere else. You have too much information. And I'm sorry to hear that, but that's your problem. You have to sort it out. So your brain has to take all this information and going upstream, or I guess downstream, saying, all right, is it a language thing I'm listening to, or are the visual spatial aspects more important? Well, the left hemisphere picks up the language stuff, the right hemisphere picks up the visual spatial, non-linguistic stuff, and then it goes up to the frontal lobes, which are the center of your personality, your decision-making, your ability to inhibit or not inhibit, and the frontal lobes have to make sense of all this sensory information. And then the frontal lobes, once it conceptualizes, does a logical analysis, you get reasoning. Should I say this? You know, should I correct what this guy's saying because I know it's hogwash? Well, maybe it wouldn't look good. Dr. Keller might not write him back, but he's no good, so maybe it'll be good if he doesn't come back. You know, you can analyze what to do or what not to do. And often, if you have damage to your frontal lobes, that's what you have a problem. You can't inhibit. And there's a whole syndrome of disinhibition, where people with frontal lobe lesions will act inappropriately, behavioral consequences mean nothing to them. They will just be their own person, and their personality really disintegrates. So that's the whole scheme of what one does with information that you're exposed to. The key to all this is right there. It's memory. Because your personhood is your memory. To think about it. And I'm going to show you now a videotape of a case where specifically memory is impaired. And I want to preface it by the experience I had. I went back to the medical school where I was a faculty member for 30 years this past weekend. And I just came back yesterday. And I went back to the place I taught at for 30 years. I hadn't been back in 15 years. And it was the town in New Jersey, Princeton, that I lived in. And the whole area around there, I lived there for 30 years. I haven't been back in 15 years. And you have to live long enough to be able to look back far enough to what, you guys are too young. But, when you get old enough, you have a distance to look back. And we drove in at night, and I was passing streets that I certainly recognized. I had no idea where they went to. Which is, it was almost like a kind of impairment. Oh, Prospect Avenue, of course, I know Prospect, and Witherspoon, and Nassau. I can remember where they went, where they led to. I knew the street I lived on, of course, and I knew the medical school area. But it was almost like I had the map of where I was with all the labels, but I didn't have the roads. It was a very strange. It was almost like an impairment. Gee, I should know. Oh yeah, Raymond Road. I don't remember Raymond Road. So what it told me is what remains, and what remains is the names. Names are very, very permanent. So I'm sure you could, think of classmates you had in grade school. But, do you have really a picture of them, or do you really, know the relationship you had with them? And that's what it told me. And then as I was driving around, oh yes, of course. In fact, I was telling people who lived there which streets to take, because as I was there for 2 days, it started coming back, as I was navigating on the street. It was really interesting experience. Anyway, so I think we all thank God for our memories, because that's who we are. And I guess we should look at a gentleman who had an illness, you'll get to see, and what kinds of memories it affected in this particular case.
And do you feel absolutely normal?
Not absolutely normal, no. Confused. Confused? Yes. You never eaten anything, never tasted anything, never touched anything, never smelled anything. What about you sooner than that?
But you are.
Well, apparently, yes. But I'd like to know what the hell's been going on.
Clive was an outstanding musician. He would take his work very, very seriously. At the same time, he loved music so much that he just really threw himself into it totally.
Clive was a musician of enormous integrity.
He was the world's expert on Lazarus, one of the 3 or 4 great composers of the Renaissance.
And he also worked a great deal in contemporary music. He was chorus master of the London Sinfonietta, which is Europe's foremost.
The music flowed out of him, whether he's singing or playing or conducting.
Clive Waring, through a cruel twist of fortune, shows us how fundamental consciousness and memory are to our lives.
So how do you feel?
I'm conscious. It's the first time I've seen anybody.
You've not been conscious before?
No.
I've been here before.
I haven't seen you.
You haven't?
No. I've not seen anything at all. You've completely backed up. No test, so this is the first test.
That's the first copy you've had.
Yes. Yes.
Judith? Have you seen this?
Absolutely normal. First time. Yes. I've never seen anything the whole time I've been on. No black and white, nothing.
Do you remember me alive?
No. I can't remember any of that, so I don't remember writing any of this. No, nothing to do with me consciously. You're unconscious writing.
What are you doing here?
I don't think we're doing patients. I mean, that's the first time I've seen any cards.
Good.
Yes.
Do you remember starting again? It all started with a headache. Clive came home one day and said he had a very bad headache. The headache didn't lift, it didn't respond to analgesics. By the 4th day, he developed quite a high fever. And on the evening of the 4th day, for a little while, he forgot his daughter's name. By the 5th day, he was very delirious.
Clive suffered from viral encephalitis, which has led to the damage of the left and the right temporal lobes, plus a good portion of the left frontal lobe. Now, the temporal lobes contain a structure called the hippocampus, which we know is implicated in memory function, and in Clive it is almost certainly been completely destroyed in both sides of his brain. It's this that's primarily responsible for his severe memory impairment. In addition, the damage to his frontal lobes also causes a number of additional memory problems, which are manifest mostly in terms of him repeating himself a lot and generally showing highly emotional behaviour.
Clive's world now consists of a moment with no past to anchor it and no future to look ahead to. It is a blinkered moment. He sees what is right in front of him, but as soon as that information hits the brain, it fades. Nothing makes an impression, nothing registers. Everything goes in perfectly well because he has all his faculties, his intellect is virtually intact, and he perceives his world as you or I do. But as soon as he's perceived it and looked away, it's gone for him. So, it's a moment-to-moment consciousness, as it were, a time vacuum. And everything before that moment is completely void. And he feels as if he's awakening afresh the whole time.
I have to measure 1 night, 2.5 years on. So, that's anything to not even anything before this game. But it gives the impression of being still awake.
He always thinks he's been awake for about 2 minutes. And that's why he looks at his watch all the time to record it. To record the fact, I've woken up, this is an important event, therefore I will write it down in my diary. So he writes, 11:54 a.m. I am now completely awake for the first time. And he underlines first time. Patience begins, because he's always playing patience. And the whole diary, every page, is a succession of entries saying almost the same thing. A first awakeness. And when he goes back and looks at his own entries, he doesn't acknowledge that they are genuine. He says, he knows it's his handwriting, but as far as he's concerned, he was unconscious when he wrote them. So he quite often, he'll score out what he's written before. And so his life is an ever-repeating moment of first awakening. The strongest thing in his life, I believe, and his diary's bearing that out, is his love for me. And that's absolutely raw. And each time I walk into that room, it is as if it's the first time he's seen me for years.
Good heavens above!
Helen, you surprised to see me?
The first time I've seen any work at all. First person.
You've not seen me before this morning?
No.
How have you been here? So how are you feeling this morning?
I'm conscious it's the first time. It's the first time I've seen any work at all.
You've been conscious before? I've been here before this
I haven't
morning.
seen you before.
No, you haven't?
No. I've not seen anything at all. You're completely blind the whole time.
Don't remember me around at all?
No. No, I don't remember things what happened.
No.
I don't.
But you know who I am? Or if you kiss all of me like that?
No, I don't.
Yes, I do know. I do know. You've written all over your diary. Look. I bet you, if I look to see what you've written, you haven't mentioned me on that page. Mention me on this page. My first thought, I adore Deborah for eternity. People's entries in the diary are rubbish. What does that mean? Did you write that?
I'm not conscious. You're showing me now the first time.
Is it your handwriting?
Yes, but I know nothing about it.
So how do you think it got there?
I don't. I'm so lost in it.
You must
No, I haven't. You listen to me, please don't say. When I say no, I mean exactly that. I haven't seen the book at all till now.
No, all I'm saying...
No, that means I haven't seen it, I have no knowledge of it at all. That's all. There's no knowledge of that book at all. It's entirely new to me. Just use your intelligence. There's no type of comment with your intelligence.
Who would put that?
I don't know. No. Oh, I haven't said use your intelligence. I haven't read this in that kind of thing. Well, use your intelligence.
Clive gets extraordinarily angry, and who wouldn't? Because here you're not dealing with somebody who is demented, who is oblivious, who is gaga. You are dealing with a perfectly lucid, highly intelligent man who has been robbed of knowledge of his own life, and he feels deeply humiliated to be put in that position. very, very frustrated. He can't grasp what's wrong with him, because even as you're telling him, he's forgetting the previous sentence.
Clive has lost a form of memory which probably distinguishes human beings perhaps from all other animals. He's lost the highest form of memory that enables you to relate yourself to the past and project yourself into the future. So in a sense, he feels like a man adrift.
I haven't heard no music, any music, had any contact with music.
You're still a very good conductor. Very, very good.
Yeah. All right, we'll take a break. Any questions or comments before we do that? No question? Okay, take the break. Break's over.